sample means minus the difference in the two population means from the whole. In this case, it's going to be 0. But 3,900, just so you know where everything came from. I would be fine with you putting 400 here. That's the number that's in your whole.
Why is the number 0?
What do you have in the whole?
What?
What number is in the whole?
0.
0. Why is it 0? Because of the way they said this. That there is a difference. They didn't say the difference was $500. They didn't say it was more than $200. They just said there is a difference. So all I know is they are not equal. Then I just did some algebra and I subtracted the mean of New York from this side. Well, if I take the mean of New York and I subtract the mean of New York, what do I have left here? 0. That's where the 0 came from. Just shifting that over to the other side and writing it as a difference. Okay. The bottom part of the formula says, what is this S1 squared business? Yeah, it's the standard deviation squared. It's the variance. So my 1 is my New York, no, what do I got first? My New Hampshire stuff. So New Hampshire is what my 1 business is. So I've got 900 squared over the sample size of 50 plus, well, because I'm adding, I guess it doesn't matter, 500 squared over 50. Is this a bit of a calculator challenge? Yeah.
Can you put it on the screen? Show you do it?
Sure. Any questions on what I get? Or was that right? 2.7. 2.75. Any problems getting that? Okay, where's 2.75 land on this graph? In the shaded over here, so what does that tell me? Reject the whole. What does it say about the claim? Claim is true. So that $400 difference that there is a significant difference. It looks like the people from New Hampshire are putting more money on a credit card than New York people. Okay, let's try one more with the program. It's getting the claims right. That's going to be the challenge for you, I think, today. Okay. Hey, the American Automobile Association, we've got AAA making some claims here. AAA. Make sure I did it right this time. Claims that the average daily meal and lodging costs while vacationing in Florida are greater than the same average cost while vacationing in Maryland. Okay. So their claim is that the vacation costs in Florida are higher than the vacation costs in Maryland. And here's our sample data. It was average cost. Average costs in Florida are higher than the cost of average vacation costs in Florida. Gotta have our mean in there so we don't fibble we're working with. Okay, sample. Florida, Maryland. Florida, the average was 252. Standard deviation, 22. Sample size, 150. Definitely over the 30 that we needed. Maryland, 244. Standard deviation here, 18. 200. So the sample sizes do not have to be the same. They just have to both be over 30, or greater than or equal to 30. Okay. Claim. In symbol, which we'll rewrite as a difference in a minute. How do you write that the average cost in Florida are higher than the average cost in Maryland? Greater than. Do 6? Oh. The mean for Florida. What are they saying about the mean for Florida? Greater than the mean of Maryland. Could I just as easily say the mean of Maryland is less than the mean of Florida? And go through the test? Yeah, that means the same thing. Okay? I can't leave the claim this way. I have to rewrite the claim as a difference between the two, from comparing the difference. So the real claim is after I shift this over by subtracting it on both sides. So I'm going to subtract the mean from Maryland from both sides of this inequality and use that as my real claim for the test. What do I have it being greater than? 0. Does that make sense to you? So that makes the claim. Less than or equal to 0 is the hope. Okay, when we run programs, we always want the p-value, the probability of that sample, and we compare it back to alpha, and we're going to use alpha at 5%. So the program is called I'm glad I wrote it down. I'm pretty sure it's 2SAMP z-test. I wouldn't bother writing that down. Oh, there it is. Program is called 2SAMP z-test. And at this point, it should be, I think you'll probably be pretty good at knowing what to put in each spot of the program, but let's go through it. Test. Why, but tomorrow, 2SAMP t-test. Oh, not quite tomorrow. Okay, number 3. 2SAMP z-test. Everybody there? Sigma 1. What do you think we're talking about here? Standard deviation. What am I calling 1 according to my claim? Florida is going to be my 1 because that's what I wrote first here. So these are going to be my sub 1 numbers. These are going to be my sub 2 numbers. Sigma. It means, standard deviation. It means population, but the best we can do is use the sample. So, 22. The other one is 18. X bar 1. Everything with 1 is coming from my Florida. It's all about labeling things right. So 252. N1, 150. X bar 2, 244. N2 is 200. What do we want to highlight here? The Ha sign, always the Ha sign. The Ha is pointing to the right, so that's the middle one, the one I've got highlighted. And then calculate. Did I do the wrong one? Oh, I did do the wrong one. Over here. Ah. See, there's that tired brain. There it is. 1.4 times 10 to the negative fourth. You know that's a probability. It can't be over 1, so that's why I knew it was scientific notation. If I look on the end of that long line of digits. How does P compare back to alpha? Smaller. P is smaller than alpha. What decision do we make? Do you remember? It's reject. If it's very small probability of happening, it's reject. Reject the hoe. That makes the claim true. Okay. We are going to spend another day in this section where the difference is not 0, but that's tomorrow. And confidence intervals. We might not be here tomorrow. But assembly. I think it starts in second hour.
And then it goes to the other.
Well, we'll just do it the next day. You guys will be a day behind. Okay. Don't plan on it. I don't know what time that starts. So we have class tomorrow, Keenan. We're checking. You're responsible to have this ready to go. 5%. I snuck that in later.
Okay, I was gonna say.
Page 373. 7, 8, and 9 by hand. 11 and 12 program. Nope, plan on tomorrow. I don't know what time, unless I can find out what time the assembly is.